Hello, today's offering is on writing chemical formulae and what they mean. Now, chemical formulae are one of the things which are particular to chemistry. It's a shorthand and it gives us so much information about substances. It tells us what elements are present and also the number of atoms of each element. So, without further ado, so if we look at the example here of calcium carbonate, so the number of elements each time there's a capital letter means there's a new element. So in calcium carbonate, we've got 3 elements: calcium, carbon, oxygen. Atoms, we need to look at the formula again. So we've got 1 atom of calcium, 1 atom of carbon, and because there's 3 at the base there, we've got 5 atoms in total. Now, this is a fairly straightforward thing that goes on throughout. So if we look at copper nitrate, doing the same sort of thing again. 1 element, 2 elements, 3 elements. So elements equals 3. Atoms, and this is with a bracket, we have to remember our maths, our BODMAS. So we've got 1 copper. Now, because there's 2 outside the bracket, that means there are 2 nitrogens. And also, because there's 2 outside the brackets, that means there are 2 3s are 6. So we've got 1 copper, 2 nitrogens, and 6 oxygens. So that comes to a total of 9 atoms. Okay, that's the only difficult bit, is looking at the brackets. Okay. In writing the formulas for some substances, if we look at the prefix, this is the little bit which goes in front of the element. It will often tell us the number of atoms. So, for instance, if we've got mono, that means there's 1 atom. If it's di, that means there's 2 atoms. If it's tri, it means there's 3. And if it's tetra, it means 4. So I'm sure you all know this. So if we look at carbon dioxide, carbon we know is C, oxygen is O, and this prefix di means there are 2 oxygens. So CO2. Sulfur is S, oxygen is 3. Now the prefix there, tri, means there are 3. So SO3. Not that many of these, but they're fairly straightforward. Now, the main way of writing chemical formulas is from looking at the charges. As we know, the charges on ions come from elements which have lost or gained electrons. If you lose electrons, you have a positive charge. If you gain electrons, you have a negative charge. Now, the most important thing with this is that a chemical formula is correct when the positive charge is equal to the negative charge, so they cancel each other out. Now, the important thing you need to know about this, you need to know the charges on individual ions. Now, here is a table of individual ions. So, we've got hydrogen. So, all the metals are positive. Hydrogen, sodium, silver, potassium, lithium, ammonium are all +1. Barium, calcium, copper, magnesium, zinc, lead, iron 2 are +2, and iron 3 and aluminium are +3. Now, in most cases, if they're in group 1, they're +1. If they're in group 2, they're +2. And the nice thing is, if a substance, an element has more than 1 ion, it will tell you the charge in brackets. So iron 2 there means it's +2. Iron 3 means it's +3. Now, For the negative ions, we've got chloride, bromide, iodide, and fluoride, -1, hydroxide -1, nitrate -1, oxide -2, sulfide -2, sulfate -2, carbonate -2. So all the halogens, group 7, are -1, and group 6 are -2. So don't try to learn the group 1, the group 2, or the group 3 charges, because you'll have the periodic table. Likewise, the group 6 and the group 7. Learn the ones which aren't in there. Now, how we do this? So, I've looked at here 3 different types of formulae. So, simple formula with equal charges. So, the example is sodium chloride. So, if we look at sodium, right at the top there is Na, and it's +1. If we look at chloride, it's Cl, and it's -1. Now then, as these charges are equal and opposite, it just becomes NaCl. They cancel each other out. Similarly, let's look at zinc oxide. Zinc is Zn and +2. Oxide, as you can see from here, is O and it's 2-. Now, again, because these charges are equal, they cancel each other out, so you just need 1 atom of zinc and 1 atom of oxygen. So the formula is ZNO. Now, the more common case is where the charges are different. So, if we look at the example, potassium oxide. So, potassium is +1, and oxygen, as we've seen, is -2. Now, what we need to do here now is to find the lowest number that each will go into. And both 1 and 2 will go into 2. 1 will go into 2 twice. 2 will go into 2 once. And we don't ever bother writing ones down, so it just becomes K2O. Okay, let's look at a few more. Aluminium fluoride. So aluminium, as you can see, is Al, and it's 3+. Fluoride, as you can see at the top there, is F, and it's -1. Now, the lowest number they will both go into is 3. So 3 goes into 3 once, and 1 goes into 3 times. So the formula is AlF3. Now, slight variant here. This is lead 4. So it means the charge on lead is +4. Oxygen, as we know, is O and is 2-. Now, the lowest number that both of these will go into is 4. 4 goes into 4 once. 2 goes into 4 twice. So it's PbO2. And getting really at the tough end of this now, aluminium, 3+, and sulfide is 2-. Now, again, the lowest number that both 2 and 3 will go into is 6. So 3 goes into 6 twice, 2 goes into 6 3 times. So we've got Al2S3. So the key point to remember there is you find the lowest number that both will go into. Okay, the last ones, which I call the complex ions. Now, complex ions is where we have an ion is made up of more than one element. Procedure is the same, but we need to use brackets. So if we look at copper, so it's copper 2, we know it's +2. Hydroxide, as we can see here, hydroxide is OH and it's -1. Now, right, the lowest number both will go into is 2. So 2 goes into 2 once, so Cu. 1 goes into 2 twice. Now, because hydroxide is made up of 2 elements, and we need it more than once, we have to put that in a bracket and put that 2 outside. Right, ammonium. As you can see there, ammonium is +1 and its formula is NH4. Sulfate is SO4 and it is 2-. Now, right, the lowest number each will go into is 2. 1 goes into 2 twice. Now, because ammonium is made up of more than one atom, and we need it more than once, we have to put that in a bracket. And the sulfate part, 2 goes into 2 once, so it's SO4. So ammonium sulfate, NH4, bracket twice, SO4. And the last one, aluminium carbonate. Now again, aluminium is +3. Carbonate, as you can see there, is CO3 and it is 2-. Now, again, the lowest number that both of these will both go into is 6. So 3 goes into 6 twice, so it becomes Al2, and 2 goes into 6 3 times. Now, because carbonate is made up of more than one element, it has to be bracketed and a 3 put outside at the base. So there we are, folks, the joys of writing chemical formulas. Good luck with your practice.